This one is, the distillation unit for collecting double distillation unit. We use always distilled water in the laboratories, and for this purpose we are using the distillation set. So the ordinary water will enter into it, that will be boiled, and the vapors will enter, that will be condensed, and that will be collected. So double distillation, single distillation unit and double distillation unit. This is also very important in a laboratory. Then coming to the next one is, this one is a stirrer. When you want to stir a sample uniformly, you can connect it to it and you can on it. It will stir it very nicely. It will stir. This one is called as a stirrer, magnetic stirrer. This is a magnetic stirrer. Then there in the laboratory we have this atomic absorption spectrophotometer. AS is used for measuring the micronutrients, and flame photometer is used for measuring the potassium and other bases. So that is also available, that we can see. So by the time you can see the lab. Identification on down. What is the purpose of the tape measure? That is define the quantity of acid without harming. So we can add. That means define the quantity, 20 ml. Sulfuric acid you have to take it. Do like this and you can pour it. It's very safety also. What is this specimen?
Water.
This one is a round bottom flask. What is this one?
Core sample.
Then what is this one? Very good. Separating funnel. This is used for determining the molybdenum and all. Use this separating funnel. Okay. Quantity of soil, and the percentage will be worked out, and the total should come around, that it should be 100. When you are taking 100 gram of the soil, you should get 100. So that is the principle, Yoder apparatus. This is called as the Yoder's apparatus for the particle size distribution. Each and every seed will be of different size, and you will get a different sized particles, and you can calculate the percentage. That means what is the weight that is present in a particular seed divided by total soil taken. For example, 56 divided by 100 divided by 100 we are taking into 56. That means 56%. Like that we have to. When you total all these things, you should get 100. That is the Yoder apparatus. You can go to the lab.
Yes.
Aspirated, and then you will be excited and emission will occur, and you will get a reading also, and the reading will be displayed here. And when we do that experiment, you will understand what is the principle exactly involved, and every instrument will need a standard graph also. That remember. Whenever we except for nitrogen, phosphorus, potassium, and AAS, everything will need a standard graph. And what is a standard graph? How it can be done that I will explain in the consecutive classes. So this is a flame photometer. That one is a centrifuge. Centrifuge, you know the purpose of a centrifuge. You want to separate the particles. You take the sample and keep it in the centrifuge and you can see it. Next class. This is not for our concern. This is for biological studies. Refrigerated centrifuge. That means you take the sample and then you centrifuge it. All the particles will be light touched particles will be settling at the top, and heavy will be settling at the bottom. That principle is atomic absorption spectroscopy. This is 25 to 30 lakhs. This equipment. It's very expensive, and this is also the same principle. That is a combination of spectrophotometer and a flame photometer. Here the sample holder is, we can introduce the sample, we can get the reading here, and here also burning will occur, burning of the sample will occur, and again emission will be there, that will be measured, and that will be displayed in the display meter. This is atomic absorption. When you see a fluid and all, you just imagine that it is an atomic absorption spectrophotometer. Okay. So the values and all, this is very expensive. Every time when you take the reading, you have to change the hollow cathode lamp. For each element there is a separate hollow cathode lamp, and you have to change it. The hollow cathode lamp is very expensive. That is why this analysis is very expensive. But we have to do it. This is very important. Micronutrients are very important, and we have to do this analysis also. Okay. Equipments. We have one more advanced laboratory there, but for you, I think last time they have taken you there, Monlola laboratory. The same equipments you are having with ICP. Okay, you can go. Next time.